Hello children, today we are going to discuss chapter is matter around us pure. So when we see around us, all the things which are present around you, are they pure or they are impure substances? Today we are going to discuss about those things which are present around you. So we have two types of substances around us. We are having pure substances and we are having mixtures. Pure substances can be further split into two parts. Pure substances can be elements or compounds, and mixtures can be mixture of element with compound, or compound with compound. So, what are pure substances? A pure substance is one which is made up of only one kind of particles. That is, they are not having any kind of impurities. In a layman language, एक normal आदमी की तरह अगर सोचें तो pure देसी घी, pure butter, like that one which is not having any kind of adulteration, the one which is not having any kind of impurities added in it. It is called pure substance. Like you are having salt, sugar, oxygen, water, all these substances are called pure substances. So pure substances can be of two types, elements or compounds. Element is a substance which is having only one kind of atoms present in it. Means with the application of heat, light, electricity, you can't break up it into two or more parts because it is made up of only one kind of atoms. In our periodic table, we are having 100 elements present in it. Out of those, 92 elements are occurring in nature and rest are prepared in labs. Elements can be divided into further three groups. We can have metals, non-metals and metalloids. Metals are the substances which are malleable, they are ductile, they can conduct electricity. Like we are having iron, copper, aluminium, zinc, silver, gold, platinum, all those shiny substances, they are called metals. We are having one exceptional case, mercury, which exists in the form of liquid in nature. So what are general properties of metals? Metals are malleable, means with the help of hammer you can beat it into thin sheets. They will not break up. Like you are having gold, silver, aluminium, they can be beaten into sheets. Metals are ductile, means they can be stretched to form thin wires. That is basic principle because of which these metals can be used to make jewelry as they are malleable and ductile in nature. Metals are good conductors of heat and electricity, means they can pass electricity through them. They can allow electricity to pass through them. So, on the basis of this, we are making electric wires with these metals, and we are making our utensils for cooking also of metals because they are good conductors of heat. Metals are lustrous, means they are shiny substances like gold, silver, aluminium, copper. They all are having shine in them. So we are using them to make jewelry. Metals are generally hard. Exceptional cases are sodium and potassium, which can be cut with knife. Rest all metals are hard substances. They can't be cut with knife. Metals are strong. They are having high tensile strength, means they will not break up. They can be used to making things like bridges, buildings, railway lines, and they help us to make the buildings more strong. Sodium and potassium are the metals which can be cut with knife. They are having low tensile strength. Metals are solid at room temperature. Exceptional cases, mercury. Metals are sonorous. They can produce ringing sound when they are struck with something heavy. If you are having a bell, you are striking it with some hammer, it will produce a ringing sound. And because of this property, they are sonorous. Metals are used for making many type of musical instruments. Like we are having wires based musical instrument, guitar, sitar, tanpoora, etc. Metals are used to make different types of substances like jewelry, etc. Metals usually have silver or gray color. Exceptional cases are copper and gold. Non-metals are brittle. They exist in all the three states: solid, liquid, gas. In solid form, we can have carbon, graphite, diamond. In liquid, we can have bromine. In gases, we can have nitrogen, oxygen, hydrogen. These all are gases. So we are having all the three states of non-metals. Properties of non-metals. Non-metals are brittle. They can't be beaten to form thin sheets. If you are having coal, you will try to hammer it. It can't be stretched to form that sheet, but it will break up. So it is brittle in nature. They are not ductile. They can't be stretched to form wires. They are bad conductors of heat and electricity. Exceptional case is graphite. Graphite is used to make electrodes in different cells because it is good conductor of electricity. Non-metals are dull in appearance, means they are not shiny in nature. Exceptional case is iodine. Iodine is a non-metal which is having a lustrous appearance. Non-metals are generally soft. Exceptional case is diamond, which is extremely hard substance. Diamond is used to make cutters, like if you want to cut glass. तो ग्लास कटिंग के लिए जो इक्विपमेंट होगा उसके टिप के ऊपर एक छोटा सा मैग्नेट लगा है जो बहुत शार्प है. It is used to cut those. Non-metals are having low tensile strength, means they can't be stretched to something heavy. Like if you will hang something on these wires made up of non-metals, they will not be strong. Non-metals can exist in all the three states: solid, liquid, gases. Non-metals are comparatively having low melting and boiling point as compared to metals. Non-metals have low density as compared to metals. Non-metals are not sonorous. They will not produce ringing sound. Non-metals have many different colors, like different non-metals are coming in different colors. Sulfur is existing as yellow sulfur. Phosphorus is having white and red. Graphite is having black color. Chlorine is yellowish green in color, and bromine is red brown in color. So we are having different types of non-metals with different colors. Then we have metalloids. Metalloids are having properties somewhere in between metals and non-metals. These are having properties of metals as well as of non-metals. An alloy is mixture of metal or non-metal or metal with metal. They are having properties different from metals. Like you are having steel. Steel is having more strength as compared to iron. As in steel, we are adding carbon in that iron. Iron atoms are bigger in size. You can take example like you are having footballs. You are making a stack of footballs. Then there will be some voids left. In that voids, if you will fill tennis balls will fill the gaps. In those gaps, if tennis balls are fitted now, this arrangement will become more tight. Similarly, if you are having iron atoms, there are spaces for water and oxygen to get in. But when you will fill those spaces with carbon, then water and air will not get any space to come in. That means corrosion will not happen. So steel is better to use as compared to iron in many places where oxygen and water are in abundance. So corrosion can be prevented with steel. Then we are having compounds. A compound is made when two or more type of elements are combining in a definite ratio by mass and they are combined chemically. Like in water, we are having ratio of hydrogen is to oxygen 1:8. They are having a fixed ratio. In this ratio, hydrogen and oxygen are combining to form water. You can take water from anywhere. You can take water from river, you can take water from canal, from India or from Australia. This ratio will not change. This ratio will always form to be 1:8. So, irrespective of the source from where you are taking water, this ratio will not change. In compound, elements always combines in a fixed ratio by mass, and this ratio will not change. Then we have mixture. Mixture can be formed when two or more substances combines in any ratio by mass. One thing you have to keep in mind, Mixture retains the properties of its constituents. In mixture, you can find the properties of its constituents, but compound is having properties entirely different from its constituents. Suppose you are having iron and sulfur. Just mix them together, iron and sulfur. You can separate them with the help of magnet, as iron is showing property of that magnetism in it. But when you will take iron and sulfur and heat at them and form iron sulfide is a compound which is having properties different from iron and sulfur. So iron sulfide will be a black colored compound which can't be separated with the help of magnet. So properties of compound are entirely different from properties of its constituents. Like we are having hydrogen and oxygen, they are combining to form water. Hydrogen is a gas, oxygen is a gas, water is a liquid. Hydrogen is a good fuel, oxygen is supporter of combustion. Both of them are combining to form water, which helps in fire extinguishers. राइट हाइड्रोजन और ऑक्सीजन दोनों मिलके आग लगाने का काम करते हैं और पानी आग बुझाने का काम करता है. So properties of water are entirely different from properties of hydrogen and oxygen. So we are having difference between mixture and compound. Mixture is formed when two or more constituents are combined in any ratio and they are just mixed physically. But in compound formation, two or more substances are mixed by chemical process. Constituents of mixture can be separated by simple physical methods, and constituents of compounds can't be separated by simple physical method. In mixture, you can add up the elements or compounds in any ratio, but for making compound, we need a fixed ratio of constituents. In mixture, there is no fixed melting or boiling point. It just depends upon the ratio of the constituents. But in compounds, you are getting a fixed melting and boiling point as something new with entirely new chemical properties is formed. Then we have two types of mixtures, homogeneous and heterogeneous mixture. Homo means same, hetero means different. Homogeneous mixture is a substance which is formed when two or more components are mixed completely. They are not having any boundaries of separation. You are taking a container and you are having water in it. Just add 2 spoons of salt in it and dissolve it properly. From top to bottom, you will have same color, same properties. So this properties, this ratio will be same throughout. There will be no boundaries of separation. Taste, same color, same. All the measurable properties will be same. It is homogeneous mixture. In heterogeneous mixture, two or more components are added in such a way there are distinguishable boundaries of separation, like you are having sand mixed in water, right? So sand will make a different layer and water is making a different layer. There is boundary of separation between them. Then it is called heterogeneous mixture. Color will be different from top and bottom. Properties will be different from top and bottom. Taste will be different from top and bottom. So all the measurable properties will be different. Then it is called heterogeneous mixture. Then we have solute and solvent. In a solution, we have two components. Solute, which is present in lesser quantity, solvent, which is present in large excess. Suppose you are having 100 ml of water, you are adding 5 grams of common salt in it. Then 5 grams of common salt, which is lesser in quantity, is solute, and 100 ml of water is here solvent. If you will take reverse, you are taking 100 grams of common salt and you are adding 5 grams of water in it. In that case, salt will become solvent and water will become solute. So the component which is present in lesser quantity is called solute, and the component which is present in large excess is called solvent. So we have solution. A solution is a homogeneous mixture of two or more substances. like salt solution, sugar solution, or vinegar. Then metal alloys, like steel we are making. This is also a solution. Properties of solution, that is true solution. True solution is homogeneous. In it, particle size is very small. Particles of solute will be of less than 1 nanometer. 1 nanometer means 10 is to power minus 9 meter. These are so small that it can't be even seen with microscope. They can't be separated with the help of ordinary filter paper. Then they are very stable, like if you are having salt dissolved in water, it is a stable solution. They will not be able to scatter the beam of light. As the particles are very small, if you will pass torch light through it, they'll allow light to pass through them. Then we have types of solution. Solution of solid in solid, like metal alloys are solution of solid in solid. Suppose you are mixing zinc and copper and they are making brass. Then we are having solid and liquid. This is most common type of solution, like sugar solution, salt solution. These are examples of solid and liquid. Then we have solution of liquid in liquid. Like you are adding lemon juice in water, you are adding vinegar in water. Then you are having solution of gas in liquid. Like in soda water, what we are doing, carbon dioxide gas is dissolved in solution. Then solution of gas in gas, like air is mixture of gases. Then we have suspension. Suspension is a heterogeneous mixture in which small particles of solid are spread throughout a liquid without dissolving in it. Like we are having chalk powder, we are having chalk powder dissolved in water. It will make a suspension. In suspension, particle size is bigger than 1000 nanometer. Like milk of magnesia, sand particles are dissolved in water. In this, suspensions are heterogeneous in mixture and they are very large in size, more than 100 nanometer. The particles of suspension can be seen very easily with naked eye and they can be separated with the help of ordinary filter paper. Suspensions are unstable. If you will keep them undisturbed for some time, the particles of solute will start settling down as they are bigger enough to separate with the help of gravity. Suspension will scatter a beam of light if it is in disturbed state. Like sand particles are just moving and you pass light through it, then these particles will act as obstacle and they will scatter the beam of light. I'll try to explain this with the help of example. Suppose you are having something in your hand, right? And you try to pass light through it. Then what will happen? Here is torchlight. There is complete darkness in the room. Then what will happen? Light will pass through this path, this path, this path. But from this path, light will not be allowed to enter, right? So what this hand is doing, it is acting as obstacle and it is scattering the beam of light. Similarly, in case of suspensions and colloidal solution, particles are big enough to act as obstacle. So when light tries to pass through this solute particle, light is not allowed to pass. So light scatters its beam. That scattering of light is called Tyndall effect. Then we have colloidal solution. Colloid is a kind of solution in which particle sizes between true solution and suspensions. They are between 1 nanometer to 100 nanometer. Like we are having milk, blood, ink, jelly. These are examples of colloids. When you are trying to pass light through true solution, light pass through it. But through suspension, it will scatter the beam of light. The scattering of beam of light is called Tyndall effect. Then we have properties of colloids. Colloid is that which is homogeneous, but it appears to be homogeneous, but it is actually heterogeneous. Particle size in colloid is between 1 nanometer to 100 nanometer. Particles of colloids can't be seen with microscope and they can't be separated with ordinary filter paper. To separate the particles of colloid, we need ultrafiltration, or we can centrifuge them. With the help of centrifugation machine, you can separate its components. Like we can separate fat from milk, cream from milk with the help of centrifugation. This is technique by which fat can be separated from milk, which is a colloidal solution. Then what is Tyndall effect? It is scattering of beam of light. You can see in a dark room, there is scattering of beam of light through this room. That is called, it is making a cone-like structure. Or you can see in a dark, dense forest, if light is coming between the trees, it scatters the beam of light. It is called Tyndall effect. Then we have classification of colloids. These can be of different types. We have sol. Sol is a colloid in which tiny solid particles are dispersed in liquid medium like ink, soap solution, starch solution, and most of the paints. Then we have solid sol. Solid sol is a colloid in which solid particles are dispersed in solid medium. Example, colored gemstones like ruby. Then we have aerosols. Aerosol is a colloid in which solid or liquid is dispersed in gas. Examples of aerosols, that is solid is dispersed in a gas, is smoke or automobile exhaust. Then we have emulsions. Emulsion is a colloid in which minute droplets of one liquid is dispersed in another liquid and they are not miscible like milk, butter, face cream. Then we have foam. Foam is a colloid in which gas is dispersed in liquid medium like fire extinguisher foam, soap bubbles. Then solid foam. Solid foam is colloid in which gas is dispersed in solid medium like foam, rubber जिनके अंदर air आ जाती है. Then we have gel. Gel is a semi-solid colloid in which there is continuous network of solid particle dispersed in a liquid like jellies, gelatin, hair gels. Then we have a most important topic, that is numerical of concentration. For finding this concentration, we need to understand two terms: dilute solution, concentrated solution. Dilute means which is having lesser amount of solute, and concentrated solution means which is having more amount of or more concentration of solute in that solution. For finding the concentration mathematically, we have a formula. Concentration of solution is equal to mass of solute by mass of solution into 100. Like we are having a question, a solution contains 30 grams of sugar dissolved in 370 grams of water. Calculate concentration of the solution. First of all, we need mass of solution. Solution is comprising of two components, solute and solvent. Solute is 30, solvent is 370. So it is making 400 grams. Concentration of solution is equal to mass of solute by mass of solution into 100. So 30 upon 400 into 100 is making 7.5%. Then we have saturated and unsaturated solution. Suppose you are having 100 grams of water and you keep on adding salt in it. By the time it is dissolved in water, जितनी देर तक वो dissolve होता जा रहा है, it is unsaturated solution. And at one point it will stop dissolving in it. At that time it will make saturated solution. Common salt 36 grams can be dissolved in 100 grams of water at ordinary room temperature 25 degrees Celsius. It will make saturated solution. Below 36, if any value of common salt is added in water, will make unsaturated solution at ordinary temperature 25 degrees Celsius. But if you will increase the temperature, more amount of solute can be dissolved in it. In that case, it is called supersaturated solution. When supersaturated solution is allowed to stand for some time, it will come at room temperature, then extra amount of salt that was dissolved in it will start settling down in the form of crystals. This is basic principle of crystallization. Then on solubility, what is solubility? Solubility means maximum amount of solute that can be dissolved in 100 grams of solvent at specified temperature. Solubility increases with increase in temperature and decreases with decrease in temperature in case you are going to dissolve a solid in a liquid. But in case of gases, if a gas is dissolved in liquid and you start heating it, then gas will start bubbling out. Means with increase in temperature, solubility of gas in liquid will decrease. But on increasing pressure, solubility of gas in liquid will increase. Like carbon dioxide gas is dissolved in soda water cold drinks with the application of high pressure, because it can be dissolved with the application of pressure. Question is, 12 grams of potassium sulphate dissolves in 75 grams of water at 60 degrees Celsius. What is solubility in water at room temperature? So 100 grams of water will dissolve. How much quantity you have to find? 75 grams of water is dissolving 12 grams. So 100 grams will dissolve 12 upon 75 into 100. Simple unitary method, we will get 16 grams of potassium sulphate can be dissolved at 60 degrees Celsius. Then we have last topic, physical and chemical changes. Physical change means a change in which no new substance is formed. Only state of substance is changing. Like water is changing to ice, ice is changing to water. Water is changing to steam, steam is changing back to water. These are the changes in which no new substance is formed. Only form of water is changing. That is called physical change. A chemical change is that in which new substance with entirely new chemical properties is formed. Like you are having burning of paper. In that you are getting ash, which can't be converted back to form paper. Then we have difference between physical and chemical changes. In physical change, no new substance is formed. In chemical change, new substance with entirely new chemical properties is formed. A physical change is a temporary change which can be reversed back easily, but chemical change can't be reversed easily. So in physical change, no new substance is formed. In chemical change, new substance with entirely new chemical properties is formed. That's all about this topic. Thank you.